Hello everyone, I am Dr. Vibha Bora, Associate Professor in Electronics and Telecommunication Engineering Department in GH Raisoni College of Engineering, Nagpur. Today, we will discuss the introduction of electromagnetic fields. Before starting the introduction, I want to say one quote by Albert Hubbard that one machine can do the work of 50 ordinary men, but there is no machine that can do the work of an extraordinary man. So, we will start the introduction. Electromagnetic fields. Electromagnetic fields is the interaction between the electric charges at rest and in motion. Electromagnetic fields, basically it is the analysis of electric and magnetic fields in free space. Electromagnetic fields find various applications in microwave, antennas, satellite communication, radar, nuclear research, remote sensing, electromechanical energy conversions, and many more are there. Electromagnetic fields are used in induction heating for melting. Electromagnetic power can be used in the form of short waves and microwaves to heat the deep tissues to change the pathological conditions. Electromagnetic power are useful in agriculture also in a very beautiful and new applications, like we can change the taste of the fruits. It is used to change the taste of the fruit by reducing the acidity of the vegetables. So, electromagnetic fields find a very wide applications in many areas today. To discuss the electromagnetic field, the important tool which is required is vector analysis tool. So, vector analysis tool, in this, as we all of you know that there are two types of quantity, scalar and vector. As scalar is the quantity in which only the magnitude is there, while vector is a quantity in which it has magnitude as well as direction. So, a vector is basically a quantity having magnitude and direction. So, any vector can be represented like this. Vector A with one bar, or in some books it is represented like this. It is a bold letter A. This is the vector quantity. Example of the vector quantities are like a gravitational force acting on a body, it's a vector quantity, or you can say the velocity of the air drop in atmosphere, it is also a vector quantity, fine. So, vector is basically magnitude as well as direction. Now, to understand the direction of the vector, we will discuss unit vector. Unit vector is the quantity represented like this, A, this. Now, what is unit vector? Unit vector, as we know that a vector is having magnitude as well as direction. So, the direction of any vector, for example, we will discuss this vector A. This vector A is represented in magnitude like this, mod of A or simply A. This is the magnitude of any vector. While the direction of any vector is given by a unit vector. Unit vector is the thing, like this is unit vector. So, unit vector is the quantity in which it has a magnitude 1. So, unit vector is having magnitude 1 and it is directed along the vector A, like here in suffix we have written vector A. So, unit vector A is always directed it gives the direction of the vector. So, if you want to express unit vector A, it is simply that vector upon its magnitude. So, this is what unit vector. So, in general, any vector A is represented like this, magnitude with direction. So, this is what any vector in general, it is written like this. This is what the magnitude and this is what the direction of vector A. Further, any vector A in Cartesian coordinate system. Cartesian means rectangular coordinate system. Any vector can be represented like this. Vector A, Ax plus Ay here Ax, Ay and Az. This Ax, Ay, Az are called as components in x, y and z direction. Now, what is Cartesian coordinate system? It is a system in which it is a three-dimensional system in which x coordinate, y coordinate and z. The axis is like this, x, y, z, which are mutually perpendicular to each other, and Ax, Ay, Az, these unit vectors are the unit vectors in x direction, y direction, z direction respectively. So, this is in general a Cartesian coordinate system. Any vector can be represented like this. Further, when we want to do the vector addition and subtraction, the things are like this. Vector addition, we can add two vectors, we can subtract two vectors. There are two methods to do this. Vector addition, it can be done by two methods, triangle method and parallelogram method. For example, if we have two vectors, vector A, vector B. If we want to add want to sum or we want to add these two vectors, they cannot be directly added. They can be added by using the addition method. The first method is like this. Draw first vector as it is. Draw first vector as it is. This is vector A. This is called as tail of vector A. This is called as tail of vector A. This is called as head of vector A. Then for the vector B, this is tail, this is head. Put this vector as it is over here on the head of vector A. The tail of vector B is placed. This is vector B. So, what will be the result? A plus B, for example, the vector addition, the result will also vector, it will be A, vector A plus vector B, let it equals to vector C. Then join a line from the starting point of vector A and the end point of vector B. This is the result C by vector addition method. So, this is one way to add two vectors. There is another way, which is the parallelogram method. In that, what we do is, these are the two vectors. The starting points of two vectors are placed at one point. Then, what we do, we draw the parallelogram. We draw one parallel line, this parallel line to vector B from the vector A. This is one. Then draw parallel to vector A from here. The diagonal will be the resultant C. This diagonal will be the result C. So, this is what by parallelogram. So, we can add the two vectors by two methods. The answer will be same by any of the method. Or if you want to do the subtraction, to do the subtraction, what is important will vector C equals to A minus B. How to get this? Here what we do, we want to do A minus B, that is same as A plus minus B. So, what is here? We want to do simple addition, but addition of what? Vector A and minus of vector B. Now, what is minus of vector B is? Just see vector B here. See here vector B. How it is? It is like this. So, first take the just opposite 180 degree phase shift of vector B. How it will be? Let this is vector A and this is vector B. Then the 180 degree opposite vector, that is minus b, will be this, of exactly same length, but it will be opposite, 180 degree phase shift. This is what vector minus b is. Then further do the vector addition just as what we have done in previous case. So it will be simply like this. Vector A, vector B. So this is the resultant. This is vector C, which is A minus B. This is vector addition and subtraction. Next is vector multiplication. We can multiply two vectors by, first is scalar product, another one is, this is also called as dot product. Why this is called as scalar? Why dot is called as scalar? Because the result, the answer of the dot product is always a scalar quantity. That's why dot product is also called as a scalar product. The second is the, like for example, first we will take here scalar product in detail. Like two vectors are there. If you want to do the multiplication, as it is a multiplication of two vectors, so the symbol dot is placed between the two vectors for the multiplication. So the result is A, the magnitude of A, then the magnitude of B will be there, then cos of theta AB. What is theta AB? Theta AB, it means that, for example, these are the two vectors A and B, then theta AB is this angle. This is the smaller angle between A and B. As there are two angles, this is the smaller angle and this is what? The larger angle. So we have to consider the smaller angle between the theta. Theta is considered to be a smaller angle between A and B. So this is what the dot product is. The result of this dot product is always a scalar quantity. That's why the answer is what? A dot B. That's why A dot B is always equals to B dot A. You can change the order. A dot B is always equals to B dot A because the answer is a magnitude, is a scalar. That's why there is no issue in A dot B or B dot A, it's one and the same. The second multiplication type is vector multiplication. As the name indicates vector, it means that the result will be always a vector quantity. That's why this multiplication is also called as a cross multiplication, because for this the notification which is used is cross, A cross B. So this is what? Vector A, vector B, sine of smaller angle between A and B, the similar sine of smaller angle between A and B. So this will be sine theta AB, and one vector which gives the direction, which is called as unit vector AN, which is a unit normal vector. This is unit normal vector. So in this case there are two quantities, magnitude as well as direction. So this part A B sine theta is the magnitude, which is same as the area of the parallelogram. Further, AN is the direction. So when we do the vector multiplication, the result, whatever the result will be there, it has magnitude as well as direction. So AN gives the direction of A cross B. Like this direction is given by right hand screw rule. So what is right hand screw rule? Like when we turn the screw with the right hand, if we turn the screw in clockwise direction, what happens? Screw moves downward. So the direction is downward. For example, if we move the screw in anti-clockwise direction, the screw comes up. So exactly in same way, this AN is the direction which is given by right hand screw rule. Like for example, if you consider here two vectors, So this is the direction of the result. So for example, this is A and this is B. Then if A is turned towards B, when we turn A towards B, what is the direction? What is the direction? Direction is anti-clockwise. So when we move the A cross B, when we move the screw anti-clockwise, how the screw comes upward. So this is the result. So this vector A cross B, this is the result of the A cross B. This is the direction vector. So we can write it over like AN. This is what the AN is. So this is the direction of the vector multiplication. Next, so this is vector addition, multiplication, all just we have discussed in introduction. The next is three types of coordinate systems are there. First is Cartesian, as just we have discussed here, Cartesian coordinate system. Second is cylindrical coordinate system, and third is spherical coordinate system. In Cartesian coordinate system, in Cartesian, any point P is denoted by x, y and z. So this is what a simple Cartesian coordinate system. Second is the cylindrical coordinate system, which is expressed like rho theta z or rho phi z. So what is rho, what is phi and what is z, and we will see here what is rho phi z. This is x axis, this is y axis, this is z axis. Here what is rho? Rho is the, like this is z axis for example. So this is z axis. So rho is the perpendicular distance from the z axis. So this is what my finger, this is rho. So this is the perpendicular distance from the z axis. So this is what the rho is. This is rho. When we project this rho in xy plane, so this is what phi is. So what is phi? Phi is the angle measured with respect to x axis of the rho. This is rho, this is also rho. So the rho measuring angle with respect to positive x axis is the angle phi. Then z is what? Z is the distance of the point P. Let this is point P, rho phi z. So rho is the perpendicular distance, phi is the angle made between rho and the x axis, positive x axis, z is the distance of point P from the origin on positive z axis. So this is what? Rho phi z. The limit of the rho can be, as rho is the distance from the z axis, so it is from 0 to infinity. Phi is angle made from x axis, so it is the from 0 to 2 pi. The range of the phi is from 0 to 2 pi. Z is from minus infinity to like this. This is what the positive, negative z axis, this is positive z axis. So it can take any value, negative also and positive also. So it is from minus infinity to plus infinity. So this is in short the cylindrical coordinate system. The third one is spherical coordinate system. In spherical coordinate system, any point is represented as r, theta and phi. When we see, one thing is common between this Cartesian and cylindrical, the z coordinate is same. In cylindrical and in spherical, the phi coordinate, this phi coordinate and this phi coordinate, both are same. Okay. Now what is r and what is theta? So r is basically, r is the distance of point P from the origin. R is the distance of point P from the origin, and see here, this is what the r is. This is r. R is the distance of point P from the origin. Theta is, this is z axis, x axis, y axis and z axis. So theta, it is the angle made by r with positive z axis. This is what the theta is. This is theta, and phi same as what we have discussed in cylindrical. So this is what, when we do this, when we project this r on in xy plane, this is what the projection is. So what is this? This is phi, exactly same what it was in cylindrical. So can we say like this? This the projection of r in xy plane is nothing but what? Rho. Yes, it is rho. This distance is rho and this is also rho. So this is what it is. So in spherical coordinate system, any point is represented as r, theta, phi. In next lecture, we will discuss what is Coulomb's law, what is Gauss law. Thank you.